Hello everyone, welcome back to my channel. Today let's go over a medium I just solved on my own after playing around with it a little bit and looking at a similar question and applying the same technique. So let's go ahead and try it. So basically you're given a zero index array and an integer k. You want to make it so that you want to make as many of the same number as possible based on minus k plus k minus k plus k. So what we're going to do is create a sorted list, iterate over nums, and say low and high. So n minus k and plus k. Let's print low and high so you can see. Okay, so now we want to add this interval to our sorted list. And we also want to keep track of the smallest and largest. So infinity, negative infinity, min of low. So we want to keep track of this whole range. So -1 to 8 is the entire range. We're going to line sweep over that. Goes max of largest and high. Cool. So now if we print SL, we're going to get all the intervals. And now what we want to do is just to go over -1 to 8 and find out the most frequent, like how many numbers can like 2 fit in. Like 2, for example, fits in this and this and this, but not this, so 2 would be 3. So it's like number of flowers in full bloom. But first we have to keep track of the best result, which is going to be max of c dot values. For example, this is already 4 because it's 1 has a frequency of 4. So the most frequent number is the worst case. And then let's keep track of the starts and the ends times so we can binary search over this. S and SL, starts dot append s of 0, ends dot append s of 1. And that's going to allow us to basically say if we want 3 as a number, or that's probably not the best example. If we want 1, then we don't even have to look here because 1's not going to be, if 1's smaller than this, then we don't care about it, right? So now we can go over for I in range, smallest to largest plus 1. We're going to binary search to find exactly how many intervals it fits in. So left is bisect of right because we want how many intervals are bigger than the current. So this is going to be inside of smallest and I. Right is bisect left, so the opposite of largest and I. Again, I took this idea from flowers and full blooms equals to left minus right, and then max of result and current, and then return result. So basically we're saying how many elements are smaller than the largest and how many are bigger than the smallest. So starts and ends. So as you can see, there you go, passes all test cases. So not the most efficient, but again, I borrowed this idea from flowers and full bloom. So just finding out how many intervals a current number fits into using binary search. But other than that, I solved it on my own. So that's it for this video. Thank you for watching and stay tuned for more.